I'm Mr. Ish and I'm welcoming you to this video here, a very quick video where we're looking at the simplest complex number polar forms. Recently we've learned what complex numbers are. You can convert a complex number general form into a complex number polar trigonometric form. The modulus, the argument. If you have complex numbers, when you plot them out on the complex plane, they land right here on your axis. These quadrant axis, they are the easiest ones to represent in terms of polar or trigonometric form. Anything landing right here would have the form z is equal to r cosine 0 plus I sine 0. An example of that could be z is equal to, let's just say, 4. When you compute all of this, you'll have something like this: a real number component, the imaginary number component will go away because sine of 0 is always a 0. A complex number falling on this axis would have the representation z is equal to r cosine pi over 2 plus I sine pi over 2. The exact distance between the origin to the point is exactly your modulus, so you don't even have to do calculating. You just look at that distance and that right there is your modulus. An example of this type would be z is equal to 2i, because the real number component zeroes out but the imaginary number component retains. A point right here would be like z is equal to r cosine pi plus I sine pi. An example of this could be very well z is equal to minus 3, because you know it's going to be on this negative axis with regards to x, minus 3. A point right here would have a representation z is equal to r cosine 3 pi over 2 plus I sine 3 pi over 2. A representative example can be z is equal to minus I, or you can even say z is equal to minus 9i. It doesn't matter, but the real number component has zeroed out. The imaginary number component retains. In these x-axis right here, the imaginary number component zeroes out, only the real number components retain. These are quick shortcuts for you to remember. Keep all of this in your mind. Thank you.